To see what asymptotes look like, I'm going to show you a graph, and I'm going to show you how we can find those asymptotes and state them as limits using the graph. So here we've got a graph of a function here. Now those dotted lines on the graph, like this dotted line here, and this dotted line here, and this one here, and this one here, are the asymptotes. Those four dotted lines are the four different asymptotes of this graph. Two of them, this one, and this one, are horizontal, and two of them, this one and this one, are vertical. So if we want to find the horizontal asymptotes, we basically look at what those lines look like. This horizontal asymptote is at y equals -1. So there's a horizontal asymptote at y equals -1. Now this asymptote represents a specific limit. It represents the fact that this right end of the graph gets closer and closer and closer to that line as we go out to the right. So the way we can write that as a limit is we can say the limit as x goes to positive infinity of f of x equals -1. The x coordinates get closer and closer and closer to -1 as we go out to the right end of the graph. There's another asymptote, another horizontal asymptote up here at 2. That's the line y equals 2. Now if we want to express that as a limit, we notice it's this part of the graph that gets closer and closer and closer to that line. That part of the graph is what happens when x goes to -infinity, as the x coordinates get more and more and more negative. So in that case, we're going to say the limit as x goes to -infinity of f of x equals 2. Now there's also two vertical asymptotes. Vertical asymptotes. One vertical asymptote is this one here, that happens when the x coordinate is 1. Now that vertical asymptote, there's two different places where the graph gets closer and closer to that asymptote. There's one place here and one place here. In this place on top, the x coordinate's approaching 1 from the left and the y coordinate's approaching infinity. So we'd write that statement as the limit as x goes to 1 from the left of f of x equals infinity. Now it also approaches the asymptote over here. In that situation, the x coordinate's approaching 1 from the right and the y coordinate's going to -infinity. So there we'd write the limit as x goes to 1 from the right of f of x equals -infinity. Now there is a second vertical asymptote. This vertical asymptote's at x equals -2. Now in that situation, the graph approaches the asymptote here, both from the right and also from the left. As the x coordinates get closer and closer to -2, the y coordinates go up to infinity. So rather than writing two separate limits there, we can write one two-sided limit. The limit as x goes to -2 of f of x equals positive infinity.